Babs, it's Anshika. Today we're going to be going over the properties of water. Today's topics include high specific heat, high heat of vaporization, universal solvent, cohesion tension, and why ice is less dense than water. So let's get started with the basics. Water is a polar molecule, and this polarity allows hydrogen bonding to occur. The electronegativity of oxygen causes the oxygen to become slightly negative and the hydrogen slightly positive. So this is an example of a water molecule. Because oxygen is very electronegative, the electrons are pulled towards it, and the hydrogens are not as electronegative, so the electrons orbit around it less. As you can see, the oxygen has the slightly negative sign, while the two hydrogens have the slightly positive sign. So the slightly positive charges of hydrogen bond with the slightly negative charges of oxygen, and this can be seen in this diagram, where the yellow dashes are the hydrogen bonds. Always remember that hydrogen bonds occur between multiple water molecules, while covalent bonds occur between one water molecule. See this diagram for reference. So now let's get started with high specific heat. Specific heat is the amount of heat a substance must absorb to increase 1 gram of substance by 1 degrees. So water has a high specific heat because of its hydrogen bonding, which holds water molecules close together. So this high specific heat allows water to resist large temperature changes such as oceans and the moderate climate of nearby land. Lastly, because of hydrogen bonding and high specific heat, the marine biome has the most stable temperature. So now let's talk about how water has a high heat of vaporization. This means that evaporating water needs to absorb a great amount of heat. And this is also why evaporating sweat cools the body. This is because when we sweat, the water molecules on our body absorb heat from our body. So when they finally evaporate, all that heat is leaving our body. So let's move on to our next topic. Water is a universal solvent. This is because it is highly polar. So that means it is able to dissolve ionic compounds and also polar compounds. An example would be NaCl. This splits up into Na+ and Cl-. As we said, water has slightly positive and slightly negative parts to it. And the Na+ would be attracted to the slightly negative oxygen since positive is attracted to negative, while the Cl- would be attracted to the slightly positive hydrogen. In order to completely dissolve the Na+ and Cl-, hydration shells are created around them. Hydration shells are made up of water molecules that surround the ionic compound in order to separate them from each other. So let's move on to our second to last topic. Water exhibits strong cohesion tension. Water molecules are attracted to each other and create hydrogen bonds, and this is called cohesion. So because of this, water is able to move up a tree from the roots to the leaves. This is also called the transpiration pull cohesion tension, better known as capillary action. The exact definition of capillary action is cohesive and adhesive properties that function to pull water up xylem vessels. Xylem vessels are like stems, trunks, and more. Here is a sped up clip of a plant experiencing capillary action. Notice the way the water travels from the roots to the leaves to the surrounding air. So now let's have a quick talk on surface tension. It is created by hydrogen bonds, and this allows water striders to walk on water. The hydrogen bonds help keep the water strider on top of the water without breaking through. So our last topic is how ice is less dense than water. So this is because hydrogen bonds hold each water molecule farther away. When water turns into ice, the hydrogen bonds arrange the water molecule into a hexagonal shape. Since the water molecules are farther away, there's more space, which decreases the density and allows it to float on top of water. In the winter, when ice is floating on top of water, it keeps a stable temperature of the water beneath it, which allows the organisms living in it to thrive. Thanks for watching. Stay tuned for more biology-related videos.